Okay, so we're back for more. Here's that cosecant graph. Again, the idea is rather than graphing cosecant, we're going to consider 4 times the sine of x plus pi over 2 minus 3. So we'll manipulate that, and then once I have that sine graph, we'll basically just kind of rip it apart to get the cosecant graph. So for this, we have a is 4, so there's an amplitude change, so we're stretching out vertically. And then c is equal to -3, so we're shifting the equilibrium down by 3 units. So there's the impact on y. B is equal to 1, so there's no period change. And d is actually -pi over 2. Since we're adding pi over 2, that means we're going to move to the left, right, pi over 2 units. Okay, so there's our data that impacts x. So now we're ready to go start impacting things. So my points for sine, again, they all correspond to the quadrantal angles. And sine starts at 0, goes to 1, comes to 0, goes to -1, and goes to 0. So first of all, any multiplications and divisions. Well, the only thing we have is we've got to multiply all my y values by 4. So we're going to have 0, 4, 0, -4, and 0. And then these x values aren't going to change because b is equal to 1. So we're not dividing them by anything. Next thing we got to do is we got to take all my y values and subtract 3 from them. And I got to take all my x values and subtract pi over 2 from them. So that's going to create this new, let me sneak it here, it's going to create this new data table. 0 take away 3 is -3. 4 take away 3 is 1. -3. And -7. And then -3. And then subtracting pi over 2, we get a -pi over 2. Pi over 2 take away pi over 2 is 0. Pi take away -pi over 2 is pi over 2. 3 pi over 2 take away a pi over 2 is basically pi. And then 2 pi take away pi over 2, well, that's 4 pi over 2, which is 3 pi over 2. And you can kind of see that the interval hasn't changed in terms of its period. So basically, to graph this again, we've got pi over 2, pi, 3 pi over 2, 2 pi, and if you wanted to keep going out, right, 5 pi over 2, and I guess which would be 3 pi eventually, and then all their negatives, right, -pi over 2, -pi, -3 pi over 2, right, and -2 pi, just to go out some things there. And then we've got, we're going from -7 to 3, so we got 1, 2, 3, 4, 5, 6, 7, and 8. And then we have 1, 2, 3. So we've got all our scales down. So this new graph at -pi over 2, we are at -3. At 0, we're at 1. At pi over 2, we're back at -3. At pi, 3, 4, 5, 6, 7, we're down here at -7. And at 3 pi over 2, we're back at that. So we're basically just going to keep repeating this pattern over and over and over again. Okay, so here is your graph of the corresponding sine wave. All right, and then don't forget what your equilibrium is, right? The equilibrium shifted down to y equals 3. So there's our typical graph. Amplitude is 3 in both directions. So to graph the cosecant, right, to get this guy, wherever we're crossing the equilibrium, my cosecant graph is going to have a vertical asymptote. So at -3 pi over 2, -pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2, and forever and ever and ever. Wherever we're at a high point, we're at a low point for cosecant. And wherever we're at a low point, we are at a high point for cosecant. And so there is basically your graph for that crazy cosecant graph. So it's been stretched and it's been shifted and it's been basically shifted over, right? Negative pi over 2 units has been shifted over that way. And there you have it. So again, using a sine graph to create a cosecant graph, or using a cosine graph to graph a secant, and then just ripping it apart. Again, all the major things are taken care of. We know exactly where the vertical asymptotes are occurring, and I know where all my local minimums are, and I know where all my local maximums are because I've got everything clearly labeled. And so that's a really good start right there. Okay, so right now we had A, D, and C. Right, so the next round I'll do is we're going to really put it all together, and you'll see me do A, B, C, and D. All right, everybody will be present. So new round of videos coming where we really put it all together. See you guys in those videos.